Okay, let's do this question. We are given I is equal to 2 over pi. Integral pi over 6 to 5 pi over 6, 8 times the greatest integer function of cosecant x, negative 5 times of greatest integer function of cotx times dx. This is what has been given. We will have to locate the value of cosecant x with the greatest integer function being operated on it. So this is equal to, or it will produce values for x element of, we are looking for pi over 6 comma 5 pi over 6. Okay, and this is going to be giving us a value of 1 for this interval. Now this is for cosecant x, but this scenario is not going to be the same for cotx. The greatest integer function of cotx is not going to be behaving like cosecant x when the greatest integer function is being operated on it. So what we have to do is we will have to study the greatest integer function of cotx for values of x between, say, I'm going to divide this interval in the following fashion. For x being element of pi over 6 comma pi over 4. Okay, this is going to be one interval, and the next interval is going to be pi over 4 to pi over 2. The next interval is going to be pi over 2 to 3 pi over 4, and the final interval is going to be 3 pi over 4 to 5 pi over 6. So the interval is going to be split as follows: 2 over pi integral pi over 6 to 5 pi over 6. I just mentioned to you the value of cosecant x is going to be remaining as 1, but in this interval, if I were to obtain, okay, what I'm going to do is let me just split the interval and write it first. So this is 8 times of cosecant x, negative 5 times of cotx. So this is going to be equal to 2 over pi times integral. So the split is pi over 6 to pi over 4. 8 times of cosecant x, negative 5 times of cotx times dx, positive integral pi over 4 to pi over 2, 8 times of cosecant x, negative 5 times of cotx times dx, positive integral pi over 2 to 3 pi over 4, 8 times of cosecant x, negative 5 times of cotx times dx, followed by 3 pi over 4 to 5 pi over 6, 8 times of cosecant x, negative 5 times of cotx times dx. Okay, so let me give you the value for this interval for cotx. So for x being present in the interval pi over 6 to pi over 4, the greatest integer function for cotx will be giving us 1. Now, subsequently, for this interval, for x being element of pi over 4 to pi over 2, the greatest integer function of cotx, this is going to be producing us a value of 0. Now for x between pi over 2 to 3 pi over 4, the greatest integer function of cotx will produce us -1. And for x between 3 pi over 4, this is 4, right? 3 pi over 4 to 5 pi over 6. This is going to give us a value of -2. So we will have to substitute these values. So this is equal to 2 over pi integral pi over 6 to pi over 4, 8 times of 1. Okay, 8 times of 1, negative 5 times of 1, right? So this is going to be 8 negative 5. Okay, so this is going to be 5 times dx positive integral pi over 4 to pi over 2, 8 negative. For this region, pi over 4 to pi over 2, we have got the value pi over 4 to pi over 2. This is going to be 0. Okay, this is going to be 0 times the dx. So pi over 2 to 3 pi over 4, this value is producing as a -1, so it's going to be 8 positive 5 times the dx positive 3 pi over 4 to 5 pi over 6. This is 8 negative 2, that's 10 times dx. Okay, so we need to evaluate this because you have the parenthesis flowing there. So this is 2 over pi, this is 3 integrating pi over 6 to pi over 4 times the dx positive 8 times pi over 4 to pi over 2 to dx positive 8 added with 5 is 13 pi over 2 to 3 pi over 4 dx positive 18 3 pi over 4 to 5 pi over 6 times the dx. So we need to evaluate this. So let's go to the next page. So upon integrating, you're going to get 2 over pi. The integral of dx is going to be x. You have a 3 there. The limits are pi over 6 to pi over 4. 8 times of x, pi over 4 to pi over 2. 13 of x, pi over 2 to 3 pi over 4, plus 18 of x, 3 pi over 4, 5 pi over 6. Now these are all parentheses, okay? So nothing to do with the greatest integer function over here. So this is 2 over pi. You apply the upper limit minus the lower limit, upper limit minus the lower limit, upper limit minus the lower limit, upper limit minus the lower limit. So this is equal to 2 over pi. I take pi out. So this is going to be 1 over 4 negative 1 over 6. 1 over 2 negative 1 over 4. 3 over 4 negative 1 over 2. 5 over 6 negative 3 over 4. So this is equal to 2 over pi The LCM is 24. In fact, I can even take 12. So 3 negative 2, 3 pi. LCM is 4. So 2 negative 1. Again the LCM is 4. It's 3 negative 2. 18 pi of LCM is 12. This is 10 negative 9. So this is equal to 2 over pi. 3 negative 2 is 1 over 12. 8 pi, this is 1 over 4. 13 pi, this is 1 over 4. 18 pi, this is 1 over 12. So I take pi out. 3 divides here 4 times. And you have 8 over 4, 13 over 4. Now this is 18 and 12. Okay, so that would mean 3 over 2. 6, I'm using 6. 6 3s are 18, 6 2s are 12. Of course, for all these things, 4 is the LCM. So 8, 9, and that's 22. Positive 3 over 2. Pi gets cancelled. And if I take the LCM as 4, this is 22 positive 6 times 2. 2 divides here 2 times. This is 28 over 2. This is equal to 14. Okay, so that is the solution for this question. 14 is the solution. Now, just a quick tip here. Now, if you see here, I actually included cosecant x for all these steps. Actually, you don't have to do that. No, I just want to scaffold it, so that's the reason I have placed the presence of cosecant x. Now, what you can do is you can rewrite this as 2 over pi integral pi over 6 times 5 pi over 6, 8 times the greatest integer value for cosecant x dx. This is one quantity, followed by negative 2 over pi times integral pi over 6 to 5 pi over 6, 5 times of cotx dx. Okay, not cosecant x, cotx dx. Now what you have to do here is this is going to be equal to 1, right? So you don't have to include this in the calculation. You need to just include this in the calculation, right? So in that way the amount of steps and time that we have utilized here can actually be annihilated, can be avoided. So because if you see here, I have written the occurrence of 8 times of greatest integer function of cosecant x all over. Okay, so you can save that. And also the calculation part, 8 negative 5, the concept of, or I would say the presence of greatest integer value for cosecant x is redundantly occurring. So you don't have to do that. So just by negating, or I would say just by introducing this step, the solution can be arrived at a faster pace. Having mentioned that, please like, share, and subscribe. Thank you.